Hello everybody. In this video we will be looking at antiderivatives and indefinite integrals. So let me first define antiderivative. If capital F and lowercase f are functions, so that the derivative of cap f is equal to small f for all x in some interval I, then we say that capital F is an antiderivative of small f on the interval I. So pretty much if the so the antiderivative of a function small f is another function whose derivative is equal to small f. So here's an example. So the derivative of x cubed plus 2 is 3x squared, so we can say that x cubed plus 2 is an antiderivative of 3x squared. Similarly, notice that if I take the derivative of x cubed minus 4, the derivative is also 3x squared. So x cubed minus 4 is another antiderivative of 3x squared. So 3x squared here, so we see that this function 3x squared has more than one antiderivative. So both f1 of x equal to x cubed plus 2 and f2 of x equal to x cubed minus 4 are antiderivatives of the function small f of x equal to 3x squared. Now, if you look at this example, one thing you might already have realized is that whether I put a 2 or if negative 4 or it doesn't really matter. You know, if I add any constant to x cubed, then the derivative would be 3x squared. So we see the 3x squared actually has infinitely many antiderivatives, because just by adding a constant to x cubed will give us an antiderivative of 3x squared. So the one thing we want to notice here then is that the two antiderivatives of 3x squared, they differ just by a constant, right? So if you look at the difference between these two, the difference between the two is just a constant. So for example, if I subtract f2 from f1, then I get 6. So and that's actually true in general, that if I take any two antiderivatives of the same function, then they differ only by a constant. So let me justify that statement a little bit more. So if capital F and capital G are antiderivatives of the same function small f of x on some interval I, then we know that the derivative of capital F of x minus capital G of x would be equal to capital F prime of x minus capital G prime of x. But capital F is an antiderivative of small f, so it's the derivative of cap f is small f. Similarly, capital G is an antiderivative of small f, so the derivative of g is small f as well. So we get that this is f of x minus f of x, which is 0, and that's true for all x in I. And so we see that the derivative of the function f minus g is 0, identically 0 for all x in I. Well, so we have seen previously that by applying the mean value theorem, we know that when the derivative is identically 0, the function must be a constant function. But intuitively as well, should be clear. So if the derivative is 0 for all x in I, it means that the slope of the tangent line to the graph of this function at any x in I is 0. So again, the slope. So we are looking at this difference function f minus g, and the slope of the tangent line to the graph of f minus g at any x in I is 0. Well, so slope 0 means horizontal tangents, right? So that means the tangent line is horizontal at any point in I, and that kind of indicates that this function must be a constant function on this interval. So capital F minus capital G must be a constant. So capital F is equal to capital G plus C, where C is a constant. So the conclusion we want to make here is that if capital F and capital G are any antiderivatives of small f, then they differ only by a constant. So if we find one of them, then we have in fact found all of them, because let's say we found g of x, then any other antiderivative is just g of x plus some constant. Okay, so I'm going to introduce some notations here. So let's say that capital F is the antiderivative of small f, so capital F prime is equal to small f. Then we saw in the previous slide that capital F of x plus c is the most general antiderivative of small f. That is f of x plus c. So for every value of c, we get a antiderivative of small f. So capital F of x plus c, this represents the family of all antiderivatives of small f. And so we are going to denote this general antiderivative of small f by this symbol here. So this symbol is known as the integral symbol. The symbol, and I should say indefinite integral symbol. So this is a symbol that means this, and the way we read this symbol is that this is the indefinite integral of f with respect to x, and that's equal to this. But this really means the general antiderivative of small f, and in this symbol here, f of x is known as the integrand. So f of x is known as the integrand. This is called the indefinite integral of f. Again, the indefinite integral of f simply means that it is the general antiderivative of f. Okay, so c is here called the constant of integration. Here's an example. So what is the indefinite integral of 3x squared plus 3x squared dx? Now you might ask, what is the meaning of dx here? Dx simply, what dx is simply signifying here at this point is that we are integrating with respect to x. That is, we are thinking of f as a function of x, and then we are trying to find the antiderivative of that function of x. And you might say, why do we even need that? Well, because sometimes within your function there might be some other symbols like a or c or d, some other symbols or y, and then it needs to be clear what are we integrating this. So what we are integrating with respect to what variable, that needs to be cleared out. So when you have multiple symbols in the integrand. So if I look at this antiderivative of 3x, so but basically I have to find an antiderivative of 3x squared. Now from our experience at this point, I can say, well, the x cubed, right? X cubed, the derivative of x cubed is exactly 3x squared. So x cubed is an antiderivative of 3x squared. So the general antiderivative would be x cubed plus c. So that is the indefinite integral of 3x squared. So since if you take the derivative of root of x plus c, where c is a constant, then you get that the derivative is 1 over 2 root of x, and as a result I can say that the indefinite integral of 1 over 2 root of x dx is equal to root of x plus c. And one can check easily that if I take the derivative of x ln of x minus x plus c, then I get ln of x. The reason is, if you take the derivative of x ln of x by the product rule, we're going to end up with x times 1 over x, which would be 1, and then it'll be plus ln of x, and then let me check this for a second. Let me check this fact for a second. So x ln of x, okay. The derivative of x ln of x would be, so I have this, right? So the derivative of that would be, derivative of x is 1 times ln of x plus x times 1 over x. So here we are getting ln of x plus 1. Okay, so if I come back here, so notice that so here the derivative of this guy is going to give me 1 plus ln of x. The derivative here is going to give me negative 1, so 1 cancels out, so you end up with ln of x. Of course, the derivative of c is 0. So the integral of ln of x is then x ln of x minus x plus c. So here's an exercise. So capital F of x is 5x minus 2 to the 4 over 4. And we are asking, is this an antiderivative of the function small f of x equal to 5x minus 2 cubed? So go ahead and pause the video and answer this question on your own, and then come back and see my explanation for it. All right, so I hope you have paused and looked at it. So we are asking if capital F is an antiderivative of small f. Well, the way we can check it is just take the derivative of cap f and see if we get small f. So what's the derivative of cap f? Well, 1 over 4 is just a constant, and I have 5x minus 2 to the 4. So when I take the derivative, I'm going to get 1 over 4 times the derivative of this. By the chain rule, we are going to end up with 5x minus 2 to the 3, and then multiplied by the derivative of the inside here. So remember that I have 5x minus 2 to the 4, right? I wish 5x minus 2 is just an x. If 5x minus 2 is just an x, then the derivative would be 4x to the 3. But this is not just x, so I have to multiply by its derivative by the chain rule. So this is going to be 5. And so we see that after simplifying, we get 5 times 5x minus 2 cubed. So basically then we see that capital F prime isn't equal to small f, and therefore capital F is not an antiderivative of small f. So if we put 5 if we put a new factor 5 in f, then it's going to be an antiderivative. Then capital F would be an antiderivative of that. Okay, so which slide number? Okay, so now let's look at the following exercise. So let's say we want to find each of these indefinite integrals. So go ahead and take a moment and try to answer that on your own, and then we'll go over it together. Okay, so I hope you have taken the time to look at it. So if I look at it, then I know that the antiderivative, so I know from my experience that this is exactly the derivative of x to the 5. So the most general antiderivative of 5x to the 4 would be x to the 5 plus c. So that's the indefinite integral. What's the indefinite integral of e to the x dx? Well, we know that the derivative of e to the x is e to the x, so the indefinite integral is e to the x plus c. All right, so I want to write down a couple of formulas and properties of the indefinite integral. So if the indefinite integral of x to the n dx is x to the n plus 1 divided by n plus 1 plus c for n not equal to -1. So remember that when x is negative, when n is -1, then we get 1 over x, and 1 over x is the derivative of ln of x. So the antiderivative of 1 over x, we're going to look at that in more detail later, but remember that the derivative of ln of x is 1 over x. So that's why we have to put this condition, but this is known as the power rule for indefinite integrals. I guess the integral of 1 over x dx is going to be ln of absolute value of x plus c for x not equal to 0. So it turns out that that the derivative of this function is 1 over x as long as x is not 0. So when we look at the indefinite integral of 1 over x dx, we will say this is equal to ln of absolute x plus c. Integral of e to the x dx is e to the x plus c. So in your integrand, if you have a constant factor, that can be taken outside of the integral, and so you get k times the integral of k times f of x is the same as k times the integral of f of x dx. And then finally, the derivative, the integral of f of x plus or minus g of x dx is integral of f of x dx plus or minus the integral of g of x dx. So this is number 5 is telling us that we can, if the integrand is a sum, then we can integrate term by term. So the integral of a sum is basically sum of the integrals of the summands. Now here k is a constant. It has to be a constant factor, otherwise cannot be taken out. And obviously see here in 1, 2, 3, c represents a constant as well. All right, so we're going to apply these formulas now. So what is the integral of 2 dx? Well, obviously it is 2x plus c, because again, this is from this is by just, you can apply the this here where n is 0. So it is x to the 0 plus 1 over 0 plus 1, so it is x basic. So the integral of 1 is just x. So x to the 0 is just 1. So integral of 1 is x. So we have this. What is the integral of 3x to the 4 dx? Well, first of all, the 3 that we have in the integrand, that's the constant factor. So by property number 4, we can take that outside of the integral. And then I have the integral of x to the 4 by the power rule now, the property number 1. We can say this is x to the 4 plus 1 divided by 4 plus 1. 4 plus 1 is 5, so you get x to the 5 over 5 plus a c. So you get 3 over 5 x to the 5 plus c. What's the integral of 16 e to the u du? Again, 16 can be taken out. And once we take out the 16, then we're integrating e to the u with respect to u, but the integral of e to the u would be e to the u. So we get 16 e to the u plus c. Okay, what's the integral of 2x to the 5 plus 1 dx? Well, we're going to apply the formula 5, which told us that if we have a sum in our integrand, we can take the integral term by term. So we take the integral of the first term, and then we take the integral of the second term, and we add. Now here we can take the 2 out by property 4, and now we can apply the power rule. The integral of 1 is just x, because the derivative of x is exactly 1. And the integral of this guy by the power rule again, it'll be x to the 5 plus 1 divided by 5 plus 1. 5 plus 1 is 6, so we get x to the 6 over 6. And then we do a little bit of simplification. We get 1/3 x to the 6 plus x plus c. Okay, so with this, I'm going to stop this video, and in the next video, we will be looking at more examples.